In the year 2020, millions of people contracted coronavirus and hundreds of thousands died. Why do some people contract the disease and not others? If two people contract the disease, why might one have mild symptoms or remain asymptomatic while another person develops life-threatening symptoms? The reality is we don't have a scientific answer yet. And if this disease is like so many diseases, there won't be a scientific answer. Heart disease is not caused by one thing. Asthma is not caused by one thing. And so the severity of coronavirus infections will probably not be caused by one thing. It is quite possible that some variation in symptoms results from mutations in the virus, meaning that the coronavirus that infects one person is not genetically identical to the coronavirus which infects a second person. Viruses certainly mutate. In fact, one of the things that makes coronavirus successful is that it actually limits mutations. Normal RNA viruses mutate at a far greater rate than coronavirus, but coronavirus has evolved a larger genome size because it can proofread its replication and actually tamp down on mutations. But mutations do occur, and they already have occurred. So for example, by September of 2020, viral mutations had been identified in the non-structural protein 3, 4, 6, 10, 12, in the open reading frames 3 and 8, in the N protein, and in the S protein. This is the one that reacts with the human receptor ACE2. What do these mutations do? Are they significant in any way? Well, we don't know. One way of studying it would be to compare the case descriptions from various countries. Do they have the same degree of mortality? Do they seem to be infectious at different levels? Do they have the same symptoms? So far, there is some evidence that there may be differences in the nature of the infection when comparing one country to another, but these results are preliminary. It is known that there is a mutation located in the spike protein, but it does not seem to affect how this spike protein binds to human receptors. Most mutations are rare, less than 1% of the viral infections, and thus would not pose a significant risk to a vaccine, even if they do affect how a vaccine would be effective against this strain. They are very rare. The vaccine would still be effective against the vast majority. We do know that mutations in a virus could then change the efficacy of vaccines. There is an example known in MERS, coronavirus related to COVID-19, for example. Some of those attempting to answer the question as to whether varying degrees of severity of infection are caused by viral mutation are experts in the field publishing in the Proceedings of the National Academy of Science, a scientific journal which has very high standards for what is published there. Others are experts in the field publishing in another journal like New Microbes and New Infections, a journal which has high standards for what is published there. Other answers are essentially resulting from a guy who told it to a guy who read it in a tweet which was posted by another guy. Where will you seek the answers to these questions?